So in a how part, we will dig deep into that and focus on a how. Okay.
Mm, mm,
So
mm.
whatever we discussed yesterday, we need
Ah,
to take that up and consider what things are there and what things are we need to consider. So means first thing first, we need to discuss about this
mm,
design
mm, mm, mm.
environment means how
Environment,
we
yes,
can design. Yes,
yes, yes,
think and design for this environment.
right.
Then after going through the environment,
Ah,
then we need to discuss about this configuration management.
yeah, right.
Am I right? Configuration management. After configuration management, we need to discuss about this configuration drift.
Yes.
Means and after configuration drift,
Mm.
and we need to think about a rollout,
Ah, rolling out, yes, correct.
rollout as well as rollback.
Ah, yes,
Am I right?
yes.
Rollback, and after this, we need to think about
Ah, yes,
flag, and you can say this. Yes, and control release. Am I
yes,
right?
yes.
And then we need to discuss about deployment strategy,
Yes, correct.
red, green, and canary.
Yes.
And apart from that, we need to consider this readiness
Yeah.
of operation readiness,
Mm,
and apart from that, operations risk.
mm, mm.
You understand my point?
Right.
So whatever we discuss, we need to touch upon all the topics, but in
Right.
more detail.
Ah,
In a
in depth,
more
yes.
detail, yes, in depth,
Yes.
and in
Yes.
context of how we can achieve,
Ah,
what thing we need to take care and what thing we don't need to take care. Am I right?
mm, correct.
So how we can make sure this is whatever we are doing, it will achieve our goal. Am I right?
Mm, 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 mm,
So for this, you can say this designing, you can say your environment.
mm.
And first, we need to, you can say, separate
Ah,
separate our environment.
yes.
Means means clearly define what are our environments.
Environments.
Correct.
Yes.
And as we know,
Mm,
means we need to define the responsibility of
mm,
each and every environment.
mm.
You understand my point?
Right.
After defining the responsibility, we need to think of what are the resources,
Mm,
what are the resources which we need to, which
mm,
particular environment have,
mm.
right?
Right. Right.
And we need to, you can say this, we need to think of, mean, we need to divide the environment. We, you can say, divide this configuration
Mm,
resources, or you can say configuration, whatever required there.
mm,
And we also do that, you can say this, define clear environment early, uh, specific responsibility we
mm,
done,
mm.
environment resources we done, am I right?
Right.
And keep staging closely to production.
Production. Okay.
Okay, as well as how we can promote one
Mm,
environment to another.
mm.
We cannot go blindly.
Ah,
We
correct.
need to know, means, hey, this is a development environment. You
Mm,
cannot directly move to the development environment
mm.
to your this
Correct.
production. It
Mm.
should be goes to testing, then staging, then it's moved to a production. So that should be planned,
Ah.
okay, and defined,
Right.
okay.
Right.
And now we need to focus on this configuration management.
Ah, yes.
Configuration management, which is
Mm,
aspect of, then first we need to means define the structure
Ah,
of the means configuration.
right.
Right. And
Right.
apart from that, we need to externalize the
Ah,
configuration,
ah.
because first we need to means separate your code and configuration. It should
Right.
not be integrated inside a code only, because
Mm,
if it's there, then we need to read after, if something is changed, we need to redeploy our code again,
ah,
which is not a good practice.
correct.
That's
Yes.
why we need to first we need to separate, and
Mm,
second we need to you can say we need to externalize, so
mm.
that we can just means our program is or application taking the configuration from outside,
Mm,
so
mm,
that if that means we have a flexibility to change. Am I right?
mm.
And after this, we need to separate a general configuration
Mm.
and this general configuration, this your and your secret configuration. We
Okay.
need to separate those.
Separated. Okay.
Okay. And after that, we need to, you can say, separation is done, this thing is done.
Mm.
Now we need to, you can say, think of this versioning,
Ah,
means what
yes.
is the, you can say, this
Mm.
uh, things we need to care about.
Ah,
External configuration separate, general configuration, and this validate configuration, startup or
mm,
deployment.
mm.
That means configurations are there, am I
Mm,
right?
mm, mm.
And those are right or wrong. With
Mm,
the help of that, we are able to connect with our database or not, am I right?
mm.
Or we are means logs are working there or not, am I right?
Correct.
We can test that.
Right.
Okay, when means it's a starting application starting only,
Mm,
am I right? Means
mm.
we will create a one different endpoint which is called readiness and
Mm.
health.
Okay. Okay.
Okay, with the help of that means then if we have those things,
Mm.
then means we can means DevOps team can ping those
Okay.
points,
Okay.
those endpoint and check verify that. Means
Mm.
if it's a success,
Mm.
that means we are good to go. And
Oh,
if there is a failure, that means we need to do that.
pause.
Fix
Yeah.
this something, am I
Ah,
right?
okay. Okay.
And apart from that, means whatever configuration
Mm.
we have, if something is someone is changing, we need to know the traceability.
Yes. Yes.
Traceability is required. Am
Mm.
I right? If
Mm.
there is no traceability, means that time we are not able to figure out. I
Mm.
mean, the Sridhar will blame to Deepak, hey, I don't do anything. This is done
Mm.
by Deepak. Or
Mm.
Deepak will say, hey, even I don't know. This is
Mm.
done by this DevOps team. They are responsible.
Mm.
Means in a company, means multiple person have access to do this.
Right.
But if we don't have a traceability, who you will identify, how you will identify, and who
Mm.
you will ask why you do this. You understand my point?
Yeah.
And this configuration drift.
Mm.
So you need to means think configuration is, you can say, standardized setup is standard environment setup is there, which we
Okay.
already done. Am I
Okay.
right?
Yes. Yes.
It's required,
Mm.
and we need to avoid only this production only fixes.
Ah.
Means if there is a, you can say, your boss come to you, hey,
Mm.
production is not working, am I
Mm.
right? There
Mm.
should be a time window should be there. Hey,
Okay.
if something is happened,
Mm.
you don't go with a rush.
Okay.
Okay, because if you go with a rush, maybe to fix the one thing, you
Mm.
will disturb another thing.
Okay.
To fix a one issue, maybe you disturb another issues.
Yeah. Right.
Or you can say raise another issue. So for that, you need to define a process. With the help of that, you can do that. Am I right?
Right. Right. Right.
And you need to do the, you can say, proper versioning of this as
Ah,
well.
ah, 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 ah.
And you need to compare the environment. Let's say means we need to consider state close to staging is close to production. Am I right?
Yes, correct.
And if there is a difference between those,
Ah,
then this is a problem. Am I right? If
yeah,
we
correct.
not check this regularly, then this depth and difference is increased
Hmm, hmm,
day
hmm,
by day,
hmm, hmm, hmm,
which
hmm.
is not a good thing.
Correct.
Am I right?
Yes, yes.
And apart from that, we need to think this configuration drift is a production risk.
Ah, ah, yes, yes,
If you
yes.
will think that production risk, then you take care of these things.
Correct.
If you will not think like these are the production risk and this is a production risk,
Hmm.
and you will not take that risk. So
Okay.
you need to think it's a production risk
Right.
from day one. Okay.
Right. Right.
So, and if you talk about this rollback strategy,
Hmm.
so we need to make things
Hmm.
how we can roll back.
Hmm. Hmm.
Oh, means how we'll roll out. Sorry,
Hmm.
how
Hmm.
we'll roll out
Hmm.
this, and we need to means select the, you can say, this strategy there as well. Am I
Okay.
right?
Okay.
Okay, and we need to treat that as a risk.
Okay.
Okay, and we need to come up with the strategy. Which
Yes.
strategy we are going to use, because every strategy have their pros and cons. Am
Hmm.
I
Hmm.
right?
Hmm. 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 Hmm.
And we need to start with a small,
Small.
let's say with a 5% traffic only. This, am I right?
Hmm. Hmm.
And after that, we need to closely
Hmm. Hmm.
check the health. Means, hey, we are just reverting, means giving a 10% of traffic only.
Hmm.
What
Hmm.
is the what is the health
Hmm.
there?
Hmm. Hmm. Hmm.
Is
Hmm.
performing better or not? Some when it's done
Hmm.
completely, you are okay with it. Then you will expand.
Hmm. 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 Hmm.
When you done with that 10%, you are okay with your all the metric. Then you go for 20%,
Okay.
30%.
Okay.
Don't just after just doing you can increase. You cannot go for more.
Ah, right. Right.
You understand my point?
Right. Right.
So now this is a means rollback means readiness.
Ah,
Means in this we need to think about what is the impact of the data.
right.
Okay, data. What is the impact of data and what need to be reverted, and when need to be reverted. Am
Right.
I right?
Right.
What when we need to reverted, and how we can make it fast.
Correct.
Okay, so these things you need to consider for
Consider.
rollback.
Hmm. Hmm.
Okay,
Hmm.
and after that, when you have this feature flag, then you need to means make it means where chances of risk are high. Then you need to go with this feature flag, and
Hmm.
then you need to consider
Hmm. Hmm.
separate deployment from releases.
Ah, 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 ah. Okay. Okay. Okay.
Means first you need to deploy,
Yeah. Right.
not think you need to release your feature. No, first you need to deploy. So
Okay.
that we are good with the deployment part.
Hmm. Hmm. Hmm.
Means deployment is good. Now we need to means release the our feature, new feature there.
Hmm. Hmm.
Right.
Hmm. Hmm.
Means how user will able to interact with the feature. That's the difference between deployment and release.
Okay.
You understand my point?
Okay. 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 Nice. Okay.
So and then you have this use flag for risk, high risk changes,
Hmm. Hmm.
because in that manner you are good with the deployment
Hmm. Hmm.
and things are working there. Am I
Hmm.
right?
Hmm. Hmm.
And you can check with the real data.
Okay. Okay.
Okay, but you don't need to do so many, you can say, this flag,
Hmm. Hmm.
overthinking.
Hmm. 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 Hmm.
And what user can do if it's using this flag, what user cannot do.
Hmm. Hmm.
So that it should be clearly defined.
Right.
Okay.
Right.
And means if something occur, you can just off that thing so that your system will up and running.
Right.
Okay.
Right. Right.
Okay. So all these points we need to cover. So with this knowledge, means after explaining this much, you can go ahead
Okay.
and cover all other things and start from you can say you're starting.
Okay.
Okay.
Yeah.
If something
Yes.
you have
Question.
question or
Okay.
concern, we can discuss there.
Okay. Now, Deepak, I have one question. See, you told, for example, let's say a new feature I've added, and I want to roll it out to only say 5% of the users.
Yes.
Okay. Now, very base question, but still I need to know how it like. I want to know like on how do you release only to that 5%? For example, out of 100 people, now only to 20 people, 20 users. How do I deploy only to them so that they can access the new version and start using it?
So for that, as I told you,
Huh.
that person, 20% person, because we are owner of front end and back end, am I
Huh.
right?
Huh.
And contract is there, am I right?
Yes.
Then we will means introduce one more property there, one more flag.
Huh.
Hey, you need to send this flag.
Okay.
And those are our tester team.
Okay.
You understand my point?
Okay. Okay. Okay.
So, or we can launch in our, you can say this, we can launch a canary version of our app. You can say, and that time we are saying, hey, this release is a bleeding release. You will encounter some problem. If you want to test this early, it's your call, but it's not a stable. Then whomever means doing the request from that, then we are sending that flag
Okay.
because it's our implementation.
For example, Gmail is a public application where millions of users are using it. Now, Gmail has come with some new feature. They have come with a new feature. Yes, now as per your plan, they want to release it only to, in fact, in Gmail case, even if we say 1%, it run into millions. So let's say half a percent of the users they want to implement. Now it is a public site. So now there, how do we restrict, Deepak?
That's why I'm saying, because you are saying means, and based on assumption, you need to consider some assumption.
Some
Am I right?
assumption. Okay.
Let's say means if you release this based on your statics and thing, you can analyze. Hey, if earlier we release the canary version, now this much of load we will get. Am I right? So based on that, you can say, hey, now I mean this much we will load. So you are prepared for that.
Okay.
Everything is prepared. So myths come from you can say step by step. You cannot just if you are new, you cannot answer this quickly. Means now I will get a 5% because that's why this observability and metrics are there.
Okay. Okay.
Hope I'm able to answer your question.
Yes. 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 Okay. Okay. Now we will start.
Go ahead, please.
Yes. How to engineer deployment and operation safety. Why this part in real systems? Okay, yeah. Knowing deployment terms is not enough. In real system, difficult part is how to release changes safely, manage configuration reliably, reduce rollout risk, recover quickly from mistake, and operate production systems without causing avoidable outages. This module explains how to engineer deployment, deployment and the operation safety, so that so system changes can move into a production with confidence instead of fear. Correct. How to design environment separation? Yeah, we have test environment, development environment, staging environment, and production environment. Each environment must have a clear purpose. Yes, very nice. Okay. Then step 2, give each environment a specific responsibility. Yes, testing typically, development only for coding and local debugging. testing for automated validation integration, staying safe to production like an end-to-end verification, production of live users and real traffic. Yes. Third, isolate environment resources. Each environment resources, each environment should use separate database, queues, cache, storage, then service endpoint, and credentials. Correct. This prevents accidental crossover, cross environment interference. Fine. Step 4. Keep staging close to production. What does it mean here? Staging should behave as close to production as practical in OPEC topology, configuration, config style, traffic assumptions, and dependency behavior, scaling model. Okay, so keep the staging close to production critical. Right, got it. Number 5. Step 5. Control promotion between environments. Here, changes should move forward intentionally. 1 minute. Changes should move forward intentionally. Development, testing. Oh, okay. Testing, staging, production. Okay, so control promotion between environments. Okay, got it now. Changes should move forward in. Okay, fine. Then example for delivery example. New order workflow is built in development, validated by automated testing, checked end to end in staging, released to production only after operational readiness is confirmed. Fine. Now step number 2. How to engineer good configuration management. Okay, first step. Separate code from configuration. Examples of config. Database URLs, API points, feature flag, timeout values, retry policies, region values, secret references. Step number 2. Externalize configuration. Configuration should come from environment variables. Okay, config files, then config services, secret managers, deployment manifest. Do not hard code environment specific values inside your source code. Yes, today in fact in office you're facing a problem. Okay, then separate secrets from general configuration. Not all configuration is equal sensitive, correct? General configuration example, log level, feature toggle, timeout duration. Secret example, API key, DP password, certificates, and secrets. Okay, now step 4. Validate configuration startup of deployment. Validate configuration and startup of deployment. 1 minute. Validate configuration at startup or deployment. Okay. Bad config should fail early. Useful validation checks. Required value exists. Formats are correct. Endpoints are valid. The numeric values are in safe ranges. Incompatible config combinations are rejected. Okay. Step 5. Make configuration changes traceable. Team should know what changed, who changed, when it changed, which environment was affected. Beautiful. Okay. This helps auditing and incident debugging. Example. Our order service should read payment endpoint from environment configuration, retry count from config, feature flag state from external flag system, DB password from secret manager. Fine. Now step number 3. How to prevent configuration drift. This is important. Is standardize environment setup. Use repeatable infrastructure deployment definitions. Use repeatable infrastructure deployment consistently. Okay. Avoid manual production only. Yes. Temporary manual edits often become permanent hidden drift. Perfect. Then version control, non-check configuration. When appropriate, store safe config definition in version control infrastructure deployment. Compare environments regularly. Check for differences in timeout values, retries, feature flags, scaling rules, service versions, enable them. Okay. Step number 5. Treat drift as a production risk. Yes. If staging and production differ unexpectedly, testing lose value. Example, staging may use a retry count 2, while production may use a recount at 8. Okay, dependency slowdown might look acceptable in staging, but create retry storm behavior in production. Right. So, how to plan rollout safe rollouts? Treat every deployment as risky. Even small change can fail because of hidden dependency behavior, real traffic pattern, bad configuration, data differences, scaling side effects. Right. And then choose the right rollout strategy. Choose the right rollout, like yes, a full rollout, phased rollout, canary deployment, blue-green deployment, feature flag, base exposure. right? Step 3, start small. Prefer releasing to one release to internal users, one region, one service instance set, a small traffic percentage. This keeps blast radius limited, right? Watch rollout health closely. Monitor during rollouts, error rate, latency, success rate, dependency failure, resource pressure, queue growth, business KPIs. Perfect. Step 5, expand only when healthy. Do not move from 5% to 100% blindly. Expand gradually. Only the previous stage is healthy, right? A new payment retail workflow released to 5% of order traffic first. If timeout rate and checkout success remains healthy, traffic is expanded step by step. Okay.
Okay, do you have any question or concern till now?
No, it's good. No, very nicely explained. Good examples you put. No, it's okay.
Go ahead, please.
How to engineer rollback it? Yeah, this is very important. No, what is running in my background is I don't know whether even 10% of this are being implemented in my office. That is what is running in my mind. Anyway, how to engineer rollback readiness? Assume rollback may be needed. A deployment is incomplete unless recovery is planned. A deployment is incomplete unless recovery is planned. Fine. Define what can be reverted. Possible rollback targets, application version, config value, traffic routing, feature flag, dependency version, infrastructure change. Beautiful. Step 3, make rollout fast. Rollout must not depend on slow manual. How to do this? For example, uh, this little up, yeah. Rollout must not depend on manual. Good rollback methods. Previous version remains deployable. Okay, traffic can switch back quietly. Config can be restored safely. Feature flag can disable behavior immediately. Oh, it was a lot of planning. Okay, step 4. When to roll out. Define rollback triggers such as 5x error spike, business conversion drop, sustained P99 latency increase, dependency failure, queue buildup, corrupted workflow behavior. And step 4, consider data impact. Sometimes code rollback alone is not enough. If data schema change incompatibility, bad writes already occurred, event already propagated. Here, one small dot, bad writes already occurred. Can you just give an example, Deepak, bad write?
Let's say you're rolling out and whatever data should be there.
Ah.
So that has been happened. How you roll back data?
Okay. Okay, fine, right.
Understand my point?
Okay.
Because we will shift this 5% traffic for that new feature. Then the impact should be on data as well. Am I right? How you can roll back that?
And also, don't you think we need to keep track of those, for example, for those 5% of users to whom we have rolled out the new feature, and then let us say somewhere after a day or two, we encounter some problem, some spike is there in the numbers. So quickly, I want to not quickly in the sense in a phased manner. I need to roll back. So only to those 5%, I need to roll back.
Yes, definitely. Definitely, that's why we're discussing all these things.
Okay, fine. Okay.
Then feature flag can be disabled.
Disabled. And again, all this should be automatic. I can't sit there and do manually one by one. Everything should be automatically done, taken care of.
Yes. So that's the purpose of planning.
Correct. The moment I send something wrong, yes, go and change it, and then immediately it will start rolling back.
Yes.
Okay, beautiful. And now 6th point is how to use feature flag safely. Separate deployment from release. Deploy code first. Expose feature later. Oh, okay. Step 2, use flags for high risks. Feature flags are useful for gradual rollout, operational kill switch, internal testing, regional control, fallback behavior. Okay. Step 3, keep flag ownership clear. Each flag should have purpose, owner, default state, cleanup plan. Okay. Avoid flag chaos. Too many unmanaged flags make behavior hard to reason about. right? Use flags for fast recovery. If the issue is feature behavior rather than platform version, a flag can reduce recovery time dramatically. Oh, what a statement. Okay. Okay, fine. Right. Then how to use for recommendation example, a simple recommendation engine is already deployed in production, but enabled only for internal stuff. Later, it is turned on for 10% of users. When latency rises, the team disables the flag immediately without redeploying. Okay, okay. Right. How to use blue, green, and canary deployment? Yes. Use step one. Use blue green when fast traffic switching matters. Blue green works well when you need clear cutover. You want easy rollback. Infrastructure can support two environments. Okay. Flow. Blue equals current production. Green, new version. Validate green. Shift traffic. Switch back if needed. Right. Then step two. Use canary when live validation is needed. Canary works well when real traffic behavior matters. You want gradual exposure. You need low blast radius. Right. Flow. Send mail small percentage of traffic to new version. Compare metrics. Yes. Expand gradually. Stop if unhealthy. Okay.
Hold on. Do you know what is the meaning of this canary?
1 minute. Use can okay. So blue green color is color. When can use canary when live validate canary. I mean plain English meaning asking the Deepak.
Means there is a meaning regarding this name. This name comes from a particular, you can say, there is a story behind this. Am I right?
Oh.
So canary is a bird, okay,
Ah.
and means in a mines. When means we cannot move the, you can say, group of workers to start working there. First, we need to make sure
Ah.
means everything means carbon level and everything is means as accurate or as per means need human need. I mean, so they can survive there.
Okay.
So before sending to the human person, first they will you can say means put the you can say canary bird in a, you can say, this cage there. Okay.
Ah.
If the bird can survive, human can also survive. If bird can die, if bird will die, that means human cannot survive.
So that means
So
it is a living thing.
you understand my point?
So that's why it is a living thing, is it?
Yes, yes, it's a
Oh,
bird.
bird. Oh, okay, 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 okay. Oh,
You understand my point?
so this they send you first inside, and if it survives, then everything is fine.
Yes. Canary in a coal mine. Canary coal mine is a idiom for an early warning sign of yes, impending danger of failure. You
Ah,
understand my point?
okay.
So means they will do that.
Uh-huh.
Means they will conduct one test
Test.
for doing
Ah.
that.
Oh, so that it's a normal practice in all the coal mines where they go and mine. So first they look for the survival in the sense. First they send this canary. If everything is fine, then they send the people inside.
You can see here because canary have a high metabolic rate and breath faster than human. They are high sensitive
Wow.
to airborne toxins. If toxic gas were present in the mine, the bird would become sick or die before the mines were affected.
Oh.
You understand? I'm providing the vital early warning to the
To evacuate.
evacuate.
Oh my God. Oh, beautiful. Okay.
You understand my point?
Okay. Beautiful. Right.
Okay.
Okay. Flow send small percentage of new version, compare metrics, expand gradually, stop if unhealthy, guys. Compare user and system health during rollout. Compare user and system health during rollout. Yes. Okay. Good. Okay. Watch. Request success, error rate, tail latency, Then resource use, business completion rate. Okay, avoid ship and hope. What is this? Avoid ship and hope. Oh, no rural strategy should rely on, okay, blind the confidence. Okay. Ship and hope. Okay, fine, got it. Step 5, match strategy to risk. Small internal change may flow or allow faster rollout. Code payment or checkout chain needs stricter rollout controls. Example, a new order pricing service version is released to 2% of first. Metrics stay healthy. So rollout moves to 10%, 25%, 50, and then 100%. Okay, step by step. How to reduce operational risks? Step 1, automate repetitive operation. Automation reduces human error in deployment, config application, secret loading, environment setup, rollback steps. Okay. Step 2, reduce manual production changes. Manual production handling should be limited and traceable. Step 3, use checklist for critical changes before production rollout. Confirm test passed, configs validated, observability ready, rollback path ready, dependencies healthy, owners available if needed. Okay. Step 4, think about operation failure modes. Ask, what if timeout is misconfigured? What if secret is missing? What if rollout hits only some services? What if old and new versions conflict? What if staging assumptions differ from production? Okay, make risk visible. Operational risk should appear in design review. Okay, deployment planning, run books, post-incident reviews. Deepak, run books. What is run books?
Operation risk, make risk visible. Run books means you show, let's say, books, story books, give us an insight of stories. And stories are there. Novel, we will give a complete, you can say long, or you can say story. I mean, those are, it will tell us means how things are running there.
Okay. Example, a timeout increase from 2 seconds to 30 seconds may not look dangerous in isolation, that's correct. But under peak traffic, it can cause block threads, higher queue depth, and cascading failure. Right. Now, next, operational, how to prepare? Operational readiness, how to prepare. Okay, first step, confirm system is observable. Before release, ensure dashboard exists, alert exists, logs are usable, traces work where needed. Okay, fine. Prepare recovery documentation. Team should know how to roll back, how to disable risky features, how to diagnose errors, how to escalate dependency issues. Fine. Step 3, ensure access and ownerships are clear. Production changes must have responsible owners, correct permission, secure change process. Step 4, validate capacity and limits, check scaling threshold, queue capacity, dependency limits, connection pool, storage expectations. Step 5, think beyond deployment and success. A deployment is only truly successful if the system remains healthy after live traffic reaches it. Correct example, before releasing new payment connector, team confirms feature flag exists, metrics and alerts are ready, secrets are loaded correctly, rollback plan is documented, support team knows failure symptoms. Right. Point number 10, how to monitor a rollout properly. Okay, watch technical signals during deployment. Monitor CPU, memory, request rate, 4xx and 5xx rates, P95 and P99 latency, queue depth. Okay, dependency latency. Fine. Step 2, watch business signals too. Technical health may look normal while users outcome degrade. Example, order success rate, payment completion rate, delivery assignment success, car to checkout conversion. Okay, compare old versus new behavior. Where possible, compare previous version metrics, previous region behavior, control group versus canary group. Okay, look for silent features. Not all those issues appear as crashes. Example, retrace increases, async lag increases. Okay, even consumers slowing down. Partial workflow failure. Keep observations window long enough. Some failures appear only after traffic builds. Correct. Cache warm differently. Scheduled job start. Downstream dependency load goes. Example, a rollout may look healthy for the first 5 minutes, but after 20 minutes, queue, after 20 minutes, queue depth and retry start increasing, start rising. Team need to keep monitoring long enough to catch delayed failure patterns. Fine. How to handle deployment with schema or data changes? Avoid breaking compatibility. Avoid breaking compatibility. Old and new versions may coexist during rollout, so schema changes must be backward compatible whenever possible. Okay, correct. Use expand, then contract thinking. Oh, say for a sequence, add a new field or structure. Support both old and new behavior. Migrate traffic and consume. Migrate traffic and consume. Migrate traffic and consumers. Remove old structure later. Okay, okay. Do not tie risky data changes to instant full road. Correct. Later, large scheme or migration change may extract. Step plan 4. Plan recovery for partial data changes. What if deployment rolls back? What if deployment rolls back after some data was already written? Can old version still read new data? One minute data, 1 minute. What if deployment rolls back after some data was already written? Yesterday I was having this question. Okay, can old version still read new data? Is reconciliation needed? 1 minute. Okay. So now, when I made a release, I added a new field. Then after, say after 1 hour, I found there are some problems by using the metric second. There are some problems. So now I need to roll back. Now data, no new column is added. Data is written to that column. So now when I want to roll back, I need to drop that column. And then roll back to the old version, the old successful running version, and then continue. So, okay, so creation of a field and also deletion of the removal of the field has to be taken care of. So that's what it meant by if. So what if deployment rolls back after some data was already written? Can old version still read new data? No, I think, see, old version cannot read new data. The moment I sense some danger, I'm dropping the column itself. So, and old version was not designed to read the new column. New version designed to read the new column, not the old version. So, safely I need to drop that column, put back the old version, and everything works normal. Is reconciliation needed? Reconciliation, as of, I'm thinking, Deepak, you tell me whether I'm correct or not. Is reconciliation needed? See, once I drop and put my old version, I don't think so reconciliation is required.
Yes.
Okay.
Yes. Basically, it means whatever new data is inserted, that also need to be taken care or not. And that completely need to be removed or not. And so we need to, because if we are doing safely, then it means we can take a pause and think about it. I mean, there is no harm if the data is
Right. Beautiful. Very nicely put. Step the coordinate app service and data change time. Coordinate app service and data change timing. Deployment safety includes compatibility across core, database schema, events, consumers, configs. Example, if a new order service writes a new field that old consumers cannot parse. If new order service writes a new field that old consumers cannot parse, rollback comes harder. Safer design keeps old consumers working during transactions. Okay. Step-by-step real flow. Okay, example. Step-by-step real flow, real life flow for delivery. Scenario: a new order workflow is being released in production. Step 1: change is built and tested. Team completes local deployment, automated test, integration validation. Staging. Next, step 2: staging validation happens. In staging, team verifies full order workflow, payment interaction, observability signal, config readiness. Step 2. Step 3, production configuration is checked. Team confirms correct DB endpoint, correct secret references, right timeout values, and then feature flag default state, rollback instructions ready. Step 4, deployment starts with controlled exposure. New version deployed to small canary slice. Okay. Then step 5, monitoring begins immediately as team watches order success rate, payment failure, 19 latency, retry growth, service resource usage. Step 6, business and technical health are compared. If canary behaves like baseline, rollout expands gradually. Problem areas. Suppose payment timeout rate rises and order confirmation begins dropping. Okay, problem area. Fine. Recover action happens fast. Team disable feature flag or shift traffic back to old version. Step 9. Data impact is reviewed. Team checks whether partial rights and consistent order states need reconciliation. Step 10. Post-incident learning improves process. Thresholds, configuration, roller changes are improved before the next release. Okay, this is the visual promotion. Okay.
There is some problem with the iCloud.
Huh.
Okay, now it is. This is a common mistake.
Okay, when deploying without without rollback readiness. Okay, hard code. In fact, as I told you in one of my module, I think they hard coded the codes. Now they are sitting and changing it. Okay, and then release to 100%. Yeah, this is also I think the problem. I don't know this how they are doing. I need to find out how they are planning to. Is it a phased rollout or releasing it to everybody? I'll find out that. Okay. Keeping staging too different from production. Yeah, pre-release validation becomes misleading. Mistake by making manual production conflict change, manual production conflict changes. 6, monitoring only technical health, right? And then mistake 8, treating operations as an afterthought. Operational safety is part of architecture, not a separate concern. Beautiful. Okay, integrated communication. Okay, so. Deepak, it's very beautifully put. One request is, see now, can I get the MD file of this?
Everything is with you, man. Everything is with you. I already shared with day one. But you are not doing that.
No, I saw that. No. But it is not in depth like this, Deepak. If you want, I can share my screen.
No, everything is available there in this folder only. Well, hold on.